This will be the build video for the Wiki Robot. I have a couple of parts already made up, soldered up. This is the 100 RPM 12 volt N20 gear motor. Has 2 wires soldered on it. I've already determined the directions and marked one of the wires with a black stripe on it to go to ground. I'll show you how those go later, how the motor has to turn later when we get it together. This is the 3AA battery pack. I've cut a wire off to the proper length, and I've wired or soldered the red wire to the switch already. Another wire soldered to the switch is what will be our switch to power. I'll show you where it goes later. First thing we have to do is we've got to get this motor in so we can wire it up. There is a hole down here, but that wire is going to come out up here. This is let's do it this way. Let's run it up like this. Now back down. Maybe this will work better than what ways I've tried in the past. Feed those back down like that. Grab them with tweezers or pliers or whatever you got. Now we slide our motor in. This is called the motor clamp. It is marked F on the front. This is the front of the robot. So we're going to put this, it should capture this motor when the screws are running through it. But before we put the screws in it, we got to put this LED holder on it. The LED holder, this angle part goes toward the back. It just goes in here like this. My hands aren't working too well this morning. Now we're going to need a couple of 12mm by 3mm screws. It'll thread into the motor clamp. It'll just capture the LED holder. Now our motor can't go anywhere. We got to put our LED in next. We're going to orientate the thing. This is the front again. We're going to put, this is a flashing LED, a red one. The long terminal is positive, the short terminal is negative. We want the long terminal coming out the front so that we can wire our switch power to it. So to get that to feed through, we're going to bend this out, try to put a curve on it so it'll go down and come out that hole. And maybe just a little one on this one. It's hard to get everything started. That's coming out there. I got to get the one to come out the back. It is. Need to bend it a little to now we're just going to push it down in there, let them bend out as they go. And when we bend this out straight and this out straight, that'll capture our LED. And we're going to use these parts hanging out to solder some wires to. The way this works, the battery will slide in like this. But we need to get our switch over here first. This wire here is going to go up here to the LED. We have to have a 150 ohm resistor, which I think I forgot. I'll be back in a second. Well, I found my resistor. It's 150 ohm. Its purpose is to limit current through the LED. So what we're going to do, we're going to cut these off right about here, so we're not hanging out all over the place. One of these wires, these are wires from the motor. One of them goes, needs to be back over here. What we can do to make things a little bit easier, we can mount this switch where it belongs. There's a part in here called the switch clamp. It's going to go on like this. This is an 8mm screw, 8mm long. That'll hold our switch in. See the bottom of the switch coming out there. It works. Seems to work anyway. Now our battery's going to go up here. To hold the battery in, if you use see what are they, 10mm screws? Yeah, 10mm screws. You can run them through these fake cranks, and they'll actually just clamp down on the battery. That's the way I've been doing it. So that's pushed up there. I believe it goes all the way to the front, or it'll work that way. Make sure it this turns freely. Put one on the other side. These cranks are just dummies. They perform one function, but it's not the function it did on the original Wiki Robot. These are just done so that it looks kind of like the original. They spin freely. Now these pinch down on that battery pack just enough that it'll keep it from moving. If you want to use a shorter screw like an 8mm, then you could just put some hot glue, or probably enough room for double-sided tape on there. Although I think I would go with a hot glue, just a dab on the end. That way you could get it loose again. So we have our battery pack in, or switch in, and we're going to do some soldering. Or I'm going to do some soldering. I'm not sure how much of it I'm going to show. I'll show you where I'm going with it. First, we want to tie the black wire from the motor and the black wire from the battery together. We'll spin them together or twist them together, and then put some solder on them. I hope I can twist them together. I think I might have already soldered one, or tinned one, and I don't want to twist. Get the soldering iron heated up. What we're going to do is we're going to solder these two together and solder them right here to the negative side of the LED. That'll be our all our tie points, or all our connections for the negative side. We're going to do the same thing over here. We're going to take our positive motor. Well, first we need to put our 150 ohm resistor here. So let's get that ready. I'm not sure how well I'm going to be able to show this. I need to get my magnifying glass on to see the solder. But we'll try it. Our tin I'm going to tin the LED lead first. Try to tin this. I'm not exactly a big Clive on this soldering stuff, even though I've been doing it a long time. Let's get this around here. Try not to drop solder on your nice print. We can go ahead and tin the other side of the LED, the negative side. Certainly hope that I've not got that backwards. You can tell the negative side of the LED by the flat side, and I think I've got it right, looking down in there. There's a little flat on the LED body itself. Let's tin these. This is not the proper way to solder things, but it'll work for this little toy. Keep my hand steady. And we need to cut this off. You need to get the electronics going, or the electrics, not really electronics. Let's you need to get them going first so you can test it as you're building the gear train. We'll cut that. This is to the motor, the positive to the motor. We'll cut that off and strip it. Same way here. It's a little too long. Tie these together. Whoops, got it turned on. Just trying to get them to stay together long enough to solder it all up. Tin these. Tin the 150 ohm resistor. You could also use up to like a 220 ohm or somewhere in there. Depends on the LED you're using. Now we're going to solder these together. It's not easy to do looking through a phone. Missed. Looks pretty decent. Before I turn the soldering iron off. Got a flashing LED and got a motor running. That's what we want. I believe that's all of the soldering. Now we're going to start into the mechanical assembly. These two parts are in matching pairs. The shaft and the gear. So there's two sets of them. One of them has two dots. Every set has one dot. This little dot right here. And dot on the gear. This is important so that the thing will come out timed right. The one with 2 dots goes in the back. Let's do that one first. I don't think it matters if it's back or front, but that's the way I built it before. And I haven't figured out the logic yet. I think it'll work either way, but we'll go this way. With all these clawfoot and pin walkers, you have to have them out of phase one side to the other. So when this hole is up, this hole will be down. So down on this side, up on this side. So, and both of these will be up. Both of these will be down. You want to make sure you get this all right before you put a little glue on here. Make sure you know that it's working first, because after you glue these together, you might get them together if you use just a little bit of super glue, but other types of solvent glues, you're probably not going to get them apart without destroying the whole thing. So now we need our feet. I went ahead and assembled the legs and feet. This is just a screw that goes through, and it will ride in here on the and just run that around as this makes its motion around. You have to we use 8mm screws, and they have to spin freely. And this one hole is elongated just a tad to hopefully allow for some misalignment. Not too much misalignment though. We're going to assemble this side first so we can put our gear in after we get these timed. The front here and these is here, and these legs will be angled to the back. Let's go ahead and get one of them started. If the screws are too long, they'll come out on this side and interfere with its rotation. So you have to use the proper length screws, or at least not too long of a screw. Like everything here, just tighten it up a little bit to make sure it spins freely. Back off a little. Want a little play in there. Now the other 8mm screw in the front. You have to make sure that this is engaged. This screw here is engaged in the hole down here. It just sets in there. All it does is run that crank around so it looks like it's doing something. Let's try to get these where they're both straight up. These should be both straight down. Now we have to put this gear on. And it has to mesh and not throw these out of alignment. There is a slot in this gear. It makes it gives it a little give, and also shows you where the flat is. It lines up with the flat on the shaft. Otherwise it's kind of hard to tell where that flat goes. So let's do it this way. Let's run these around to the bottom, so these other ones will be on top. That way we can kind of squeeze this together See the way I'm squeezing this so that they're held together. That'll keep these at the top while I'm trying to put this gear on. And I hope that this gear fits. I'm gonna have to if you move it, you need to move them both the same. Once you get them that snapped in, you can turn it on and see if it works. And it does. This is the basics for the claw walker. It can balance on one foot, and then it just switches the feet. It's balancing on, I guess you would say. Turn that off. Now it's pretty simple. We just repeat. We would want to put some glue on here. I'm not going to do that right now. To glue the gear to the shaft. I'm not going to do that right now. I'm going to get it, make sure it's all going good first. Need a couple more 8mm screws, and I may have to steal one from something. I've got another one of these kind of built up. It's got all my screws in it. I thought I had these holes chamfered. Maybe I don't. Oh, well, I put that one on backwards. It doesn't matter. It's on the right side. Well, maybe it does. Well, I guess it doesn't matter. Let's flip it off or put it back on right just to make sure. Take it off. That's why the screw wasn't working. Try it out again. Huh. Interesting. I think I might have it one tooth off. Let's see if it changes. Not sure. You'll note I had it one tooth off. That's why it was doing this wiggle thing. That's interesting. You learn something new every day. Now it's flat. It was rocking a little back and forth as it went in its rotations. So that's very interesting. But it's got enough slop in it, I think, because of that slot, that it still worked. Well, back to what we were doing. This has got to line up. Take one out of this. This is a test bed I did. These parts, this one was all printed on my A1 Mini. All the parts come out really nice. You can probably see it. Look at these shafts, how smooth they are. Everything just turned out great. Pretty amazing. And it's fast too. These parts I printed on 2 different printers, on my Creality Ender 3 Pro and a King Rune. And the reason I did that was because I wanted to make sure that this wasn't something that if somebody printed it on just an everyday printer, it was still going to work. See if I had my tolerances right. So I built this one up. It's got a different battery pack in it, but as you can see, it still works. And I didn't have to do a whole lot of sanding or filing on it, so I'm confident that this can be built by most people. We need to steal one of these 8mm screws. Put this back in here. This saw should have just a little bit of play in it. You don't want it too tight. It'll bind up on you. So that's the mechanism, the walking mechanism. Real pleased with the way it turned out as far as the mechanics of it goes. And I believe all that's left is we need to put our body on. And once again, I am not a painter, but it is what it is. The only thing about putting the body on, when you print this body, you want supports here, 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 and right here, nowhere else. There's a sacrificial bridge down here that you'll have to cut out before the LED goes. This thing turned out great on that Bamboo Lab A1 Mini though. Very happy with the way it looks. And fast. Just make sure you don't get those wires caught underneath there like that. I believe I'm supposed to use 8mm screws again, so I'll have to steal a couple more of those. Yeah, I think we can just go with 10s. I don't think it'll hurt anything. Got to order some more screws. Just hold down here. Walks real nice. You can see the crank, the fake crank. The other one, the one in the TV show had 2 cranks. Hopefully I'll explain in the other part of this video why I had to go this route. Pretty stable, pretty solid. The feet are screwed onto the legs with, see, what did I use? 10mm screws. You could just glue them on though if you wanted to. I just screwed them on because I was making changes all along and I got tired of printing out the foot and the leg every time I made a change because I glued them together. The legs here print with supports under here. Print it just as the file will show up in your slicer, laying like that. I think that's it for building it. I'll put this. I've got a diagram of what screws to use where. And also a simple schematic showing how to wire it. Well, I think that's about it for the build portion of the video. It walks real nice. Now it does. This is not the original design I started with that I put the other video out on. That design was more or less like this. It had the 2 cranks driven by gears, just like the original robot in the TV series appeared to have from the videos that you can see online. The problem with this is it was just all way too sloppy and it resulted in a very sloppy walking motion that I just did not like. This is a much more solid walking motion. I think some of the reasons for the bad walking motion. I'm not even sure this is the one I showed in the original video, but these cranks had a long stroke on them, and the stroke was driven by two smaller gears. There just wasn't enough room to put big gears and the cranks in the same space as this. So these smaller gears, what they do is, if you're driving these gears, there's an idler gear that I don't have in here now, any slop will be severely exaggerated by these fewer teeth. So these angles will get this angle like this of the gear slop will be much greater than if the gear was larger. Also, when it's up like this and there's a little slop, when they're straight up and down or straight down, the original one didn't have this slotted thing in it. This is just some more testing I did. When they're straight up and down, just a little bit of slop down here makes this angle move greatly like this. I hope I'm explaining that well. I've already tore down the original one to get parts for the newer one. I only have so many of those motors and stuff. But anyway, all this resulted in just a way too sloppy walking motion that I just did not like. So I went with this. It's more or less the same mechanism I've used in other clawfoot walkers. Two gears. So here's what's inside this one. Gears larger gears driven by this gear from the motor that drive this bar around in unison, which makes a circular motion down here, theoretically just like these cranks, but this is a much tighter system because of just the size of the gears and just less slop all the way around. This crank here, this is a fake crank. All it does is just gets driven around by this screw right here, which is just a pin that drives that crank around and makes it look like the crank's doing something. Turn it on. Another thing about this, the old one, the cranks had to be very large because you have to have these angled feet. They have to move around each other, which requires a fair amount of stroke. If they were just like a bar, like a thin bar here, you could get by with much less stroke. Since the feet are angled, you need more stroke to get them to loop around one another. So that's the reason for the difference in the mechanics of it. I made all this black, so hopefully you can't see too much in there. You could even paint this part up here black so you can't see it.